Hello Physical Science, this is Mr. B, and we are picking up with the second part of Section 1. You remember it's about forces. Remember, a force is any push or pull that acts on an object, and we can add forces when they go in the same direction. We subtract forces when they go in opposite directions. They're going to either be equal or balanced or unbalanced forces depending on, again, what is acting on an object at any certain period of time. So we're going to actually today take a look at a specific force, and that force is what is known as friction. And hopefully you guys have heard of friction before, but to go ahead and give us a nice definition, I'd definitely write this down. Friction is a force that opposes the motion of objects that touch as they move past each other. And so the easiest way that I think to remember friction is it's basically if you push something across a table, like let's say you push your laptop across a table, your laptop doesn't just glide easily and effortlessly back and forth across the table. There's a force that is opposing that motion of the objects as they touch, again, the objects being your laptop and the top of the table. Again, if there's no friction, it would just glide effortlessly back and forth. You could just push it with your two pointer fingers, but that's not the case because there is a force that's opposing or stopping the motion of your laptop as it touches the table as they move past each other. So that's what friction is. Again, something that's going to keep something from moving, basically, without just to keep it from gliding. And there's going to be 4 types of friction. There's static friction, sliding friction, rolling friction, and fluid friction. So our first type that we're going to take a look at is static friction, and it is the friction force that acts on objects that are not moving. So static friction will always act in the direction opposite to that of the applied force. So what this means is that every object that is not moving, so if your laptop is sitting stationary on the table in front of you right now, static friction is acting on that object. It is holding that object in place. It's keeping your laptop from just sliding away from you. So that is called static friction. A way that I kind of remember it, again, my wife's an English teacher, so this might come into play, is a static character versus a dynamic character. A static character stays the same throughout the course of a story, where static friction is acting on an object that is not moving. It is staying in the same spot. So you might just think that an object moving or an object that's not moving doesn't have any forces acting on it. A non-moving object has static friction on acting on it, and we're going to see a picture here in a second that kind of makes a little bit more sense. So that's our first type, static friction. So our next is sliding friction, and it is a force that opposes the direction of motion of an object as it slides over a surface. So sliding friction is less than static friction. So if you decide now to take your laptop and push it across the table, again, you're going to feel a force that's opposing it. It's not going to glide like effortlessly across the table. That is what is called sliding friction. That force is opposing the motion of your object, the laptop, as it slides over the surface of the other object, the table. And again, it's not quite as strong as static friction, again, because static friction is holding an object in place all the time. So here is our example here. So static friction is A, and that's the potted plant. So we have forces acting from both sides of the potted plant that are keeping it in place. They're keeping it from moving at all. And on letter B, you can see we have a red arrow pointing to the left here. This is our sliding friction. So this is our force that's being pushed upon. Again, let's just say that's your little brother pushing the potted plant across the floor at your house. And so sliding friction is this little red arrow. So when your little brother pushes that potted plant, again, it's not just going to go flying all the way across the room and slam into the wall. No, it's going to feel a little resistance. That's what this red line is showing. The resistance that is felt, known as sliding friction, and this black line is showing that the plant is actually moving in that direction because the force acting in one direction is greater than the force acting in the other. So static friction is friction that's acting on object all the time, keeping it from moving. Sliding friction is when you try to push something across the surface. It is the force that is keeping it from basically flying across the room. So those are our first two, static and sliding. Our next type is rolling friction, and rolling friction is the friction force that acts on rolling objects, so like a skateboard or something like that. So the force of rolling friction is about 100 to 1,000 times less than the force of static or sliding friction. And the example they give are ball bearings in the wheels that greatly reduce friction by replacing sliding friction with rolling friction. And again, I've never been a big skateboarder or rollerblader, so an example that would kind of make this make a little bit easier to me, if we added a picture of C here for rolling friction, if we took that potted plant and we put it on a skateboard and then had your little brother give it a push, there's gonna be a lot less force opposing the motion of that potted plant. That potted plant's going to move much more. It's going to move quickly, and that's what it means when it says that the force is about 100 to 1,000 times less, meaning that your little brother could just give it a little push, and that potted plant could go flying across the room now and smash into the wall, towards that they just gave that same push with just sliding friction present. No real damage could be done. So rolling friction allows an object to move a lot easier because it's a little bit less of a friction force than static or sliding. And our last type of friction is what is called fluid friction, and it opposes the motion of an object through a fluid. So instead of having wheels or ball bearings, now we're actually going to have movement through a fluid, which can be like a water. So fluid friction acting on an object moving through the air is known as air resistance, and fluid friction increases as the speed of the object moving through the fluid increases. So we will explain more of fluid friction a little bit more in class. Sounds a little bit harder to understand because again there's kind of defining what a fluid actually is, and we will take care of that one actually in class. So that's it for this video. We'll finish up section 1, so in our next one, so let me know if you have any questions.